we're going to hopefully do a quick little section here on the converse of the Pythagorean theorem. All right, so converse is more than just a brand of shoes. All right, converse is kind of like taking a statement and making it work backwards. So the Pythagorean theorem says if you have a right triangle, then leg squared plus leg squared equals hypotenuse squared. Okay, the converse of the Pythagorean theorem says if you've got a triangle such that leg squared plus leg squared equals hypotenuse squared, then that triangle is a right triangle. Okay, so basically it says, this is what it says. It says, if c squared equals a squared plus b squared in a triangle, and by the way, c has to be the longest side, so I'll kind of like draw a little arrow down to that. Okay, so if c squared equals a squared plus b squared in a triangle, and c squared is the longest side, well, c is the longest side, I'll say, then the triangle is a right triangle. Okay. So, for example, we can ask the question then: Is the triangle with side lengths 6, 8, and 10 a right triangle? So is the triangle with side lengths 6, 8, and 10 a right triangle? Well, so let's set this up, right? So first of all, let's actually determine if it could be a triangle. Now remember, that's from a previous unit, right? How do we know if 3 particular measurements make a triangle? What must be true? You remember? Yeah, Maria? Yeah, any 2 sides have to add to be greater than the third side. Now obviously for the shortcut of that then, all we really need to check are the 2 smaller sides and make sure they add to be greater than the third side. So 6 and 8 are the 2 smaller sides, they add up to be 14, which is greater than 10. So it is a triangle, for sure. But then for the right triangle, we're going to go back to this converse. If we can show that c squared is equal to a squared plus b squared in a triangle, then we'll say that triangle is a right triangle. So let's go ahead and do that. So the 10, that's the longest side, so it's got to go in for the c. And we'll see, does 10 squared equal 6 squared plus 8 squared?
Does it matter where you put the other 2 numbers as long as the
Right, yeah, no, 6 can go in for A or B, A can go in for A or B. It doesn't matter. All right, so let's see here. So 10 squared is 100. 6 squared is 36. 8 squared is, oops, got ahead of my brain there, 64. And so those together make 100. So 100 equals 100, check. So 6, 8, and 10 make a right triangle. Okay. 6, 8, and 10 make a right triangle. All right. So let's try some other values here. Let's see. So let's try. Let's try 8, 9, and 15. Actually, I'm going to have you guys just try these. Go ahead, try 8, 9, 15. Try 15, 20, 25. Try 17, 15, 8, and then try 10, 20, 30. Okay, so go ahead and give those a shot. And I'll do them real quick and then come around and see how we're doing. All right, so Mason, that first one, yay or nay?
No.
No. Yeah, no, doesn't work. All right, how about Evan, number 2?
Yes.
Yeah. Okay. Let's see here. Mary, number 3?
Yes.
Yes. Okay, and then, oh, Shannon's not here. Patrick, what'd you say for number 4?
I said no.
No, that's correct. Yeah, it's not even a triangle, actually, right? 10 plus 20 is not greater than 30, so it's not, it doesn't even make a triangle. But yeah. So 1 is no, 2 is a right, 3 is a right, 4 is not even a triangle. Okay, cool. So, there's actually a special name for the situations where we have 3 nice whole numbers that make a right triangle, okay? Right, because if we were to just pick like any random 3 numbers, chances are they would not necessarily make a triangle. Three whole numbers like that. So any 3 numbers that work are called a Pythagorean triple. And really I should say any three whole numbers that work, because we could have, square roots and stuff like that show up. So for example, 3, 4, 5 is a classic Pythagorean triple. 8, 15, and 17, another classic. And another one is like, whoops, I don't know why I put a comma there. And then 5, like 12, and 13. Okay, you don't have to have these memorized, but they're just kind of a classic. Okay. Now, you can come up with more pretty easily, like other Pythagorean triples. For example, if we use the idea of similar triangles, right? So let's go back to that similar triangles unit. If I have a right triangle from 3, 4, 5, what could I do to these measures to get another Pythagorean triple? What, double them? Is that what you said? Yeah, double them, exactly right. So I could say 6, 8, 10. That's going to be a Pythagorean triple. Okay, or we could multiply them by 3, 9, 12, 15. That would be another Pythagorean triple. Okay. All right, or if I multiply these by 5, I would get 15, 20, 25. And that's what we just did right there. Okay, so... and there's other Pythagorean triples that are unique, that are not just, multiples of these two, but there you go. Now, this converse is actually even more powerful. So, for example here, let's see, for example, right here, when we did 15 squared for the c, the c squared was bigger than our a squared plus b squared. So if our c squared is bigger than a squared plus b squared, what kind of triangle, we can't classify it as a right triangle, but what can we maybe classify it as by its angle? Obtuse. Yeah, what made you think obtuse there, Maria?
I don't know, I kind of just guessed.
You kind of just go, well, you guessed right. So that's right, okay? The idea here is that maybe like the hypotenuse is bigger than it needs to be. So if you have a bigger hypotenuse, that means your triangle is going to be obtuse, right? Because it's like bigger than 90 degrees, all right? Whereas if your hypotenuse is like smaller, so if like your c squared is less than your a squared plus b squared, we would predict that would be then what kind of triangle? Acute, right? Okay, so then that's true in general. So if c squared is greater than a squared plus b squared, then the triangle is obtuse. Okay, so for example, if we have the sides of like 10, 36, and 38. Okay, so 10, 36, 38, if I use, Pythagorean Theorem here, 38's got to go in for the c squared, and then I get 10 squared plus 36 squared, so, 38 squared, let's see what that is. So 1,444, and then 10 squared plus 36 squared gives me 1,396. So since c squared's bigger, this triangle will be obtuse. Okay. If we were to like construct it using those sides. Okay. And then, so like I said before, also if c squared is less than a squared plus b squared, then the triangle is acute. And again, an example of that could be something like, well, actually, let's make it really easy. Let's just make it an equilateral triangle. So like sides 7, 7, and 7. Okay. So again, for this case, any of these sides could be the c, so let's just make it 7. So 7 squared is equal to 7 squared plus 7 squared. Oh, not equal to. I'm just going to put the... So you get 49 equal to c. 4 is 98. So here, the c squared is less than a squared plus b squared. It makes sense. Little triangle, we know equilateral triangles are acute. So there you go. Triangle is acute. Alright, so let me give you just 2 to try, and then we'll move on to the Pythagorean word problems that I know you guys just waiting to see. Alright, so I'm going to just squeeze this in right here at the bottom. Classify each triangle if it exists. Alright, so 9, 12, 15. 5, 13, 14. And 6, 8, 20. Okay? 9, 12, 15, 5, 13, 14, 6, 8, 20. Just classify those triangles, if they exist.
Let's take a look here, see how we did. No.
Keegan, what do you say about number 1?
It's a right triangle.
It is a right triangle. Very good. It is. Okay.
I think.
Nope, you're right. Patrick, how about number 2?
Obtuse.
Obtuse. Okay. Yeah, that's right. Obtuse. And then, let's go to Lindsay, number 3. Very good, Lindsay. It is not a triangle. That's right. Okay. Yeah, so be on your toes there, because you could totally plug this in. You could totally plug 20 in for C, square it, plug 6 in, plug 8 in, okay, and you might calculate that it's an it'll be an obtuse triangle, but the problem is that 6 plus 8 is not greater than 20, so it wouldn't make a triangle in the first place. So that's right. Okay, so any questions on any of that stuff? All right, we're going to look at some Pythagorean word problems, and you might be like, oh my gosh, there's like 50 problems. We're not going to do all of them. It's too much. And I think you guys have the major ideas down, so I think it would be kind of silly to do all of these. We are going to do at least, because I printed them out, so we're going to do at least 2 of them. But I don't know, we'll see. We'll go through this here. So, one thing I do want to kind of highlight here, so the front, this first page that I gave you, all right, well, we'll do two from this page and maybe two from the other page too then. So basically we're talking about application problems, right? So in application problems, simple radical form does not make as much sense, right? So this was trying to point out when we were talking about simplifying square roots. Sometimes we want to have the decimals. In situations like this, it's okay to use decimals, right? Okay, round to an appropriate decimal value here for problems like this. All right, having a simplest radical form doesn't really make sense when we're talking about like measuring the length or width of something. So rounding is okay. Now, let's look at number 1 here. I like this one, and then we'll work with one on the back there too. And the reason why I like looking at this one is because I don't know if you guys knew this, but when you go and buy a TV and you're buying like a 30-inch television, it is not 30 inches tall. It is not 30 inches wide. It's the 30 inches is the diagonal. And so, I don't know if you knew that or not. I always thought, like, oh, 30-inch television. That means it's probably 30 inches wide. No, it's not. It is 30 inches diagonal. Okay? So, the actual width of the television then, if you do go in and buy a 30-inch television, what is the actual width? And that TV, by the way, is like, it looks almost like a microwave. I don't even think they even make TVs like that anymore. Gosh. So, yeah, all right. That's right. Next we'll like try and find the length of someone's like club or something like that, or the distance to their cave, so how tall a dinosaur is or something. Anyway, so, alright. So yeah, we want to set up here, we clearly, hopefully, we can see that we have some right triangles going on, right? And we want to find the actual width here of this microwave TV. So yeah, Patrick?
I got the wrong tape.
Oh, you only got one of those? Here, let me get you this one. There you go, sir. Thank you. Alright, so Maria, yeah, how do we set this up?
I solved the actual. It's 18 squared plus x squared equals 30.
Yep. 18 squared plus x squared equals 30 squared. Did you... Oh, you know what? I probably didn't... Here you go. Need that one, too. Okay, now I understand what happened. Okay. All right. So that's right. So then we'll square the 18 there, and we get... What is it?
324.
Thank you. Equals 900. And then we'll subtract the 324 from both sides, right? So it's just like doing... It's just like doing a typical Pythagorean Theorem problem. So you said it was, sorry, was what?
24.
Exactly?
Yeah.
So how about that, huh? You go into a TV store, or not TV store, I don't really have those, but like Best Buy, right? You go to Best Buy, you go in like Black Friday, get a good deal on a nice 30-inch television, and then you measure the actual width, and a 30-inch television is really only 24 inches wide. And you're like, tricky Best Buy, trying to sell me more than what you really are selling me here. But that's how they measure TVs. They just never tell anyone that it's the diagonal unless you like really ask about it. But so there you go. Okay, we're getting ripped off. 6 inches there. All right, we'll look at another one here. Number 4. And in fact, I want you guys go ahead and we're going to skip over to number 4 and just go ahead and do number 4. Okay. So it's talking about a power pole. You can see that it broke very cleanly there and fell, so it's still kind of like connected and created this right triangle. So to the nearest tenth of a meter, I want to know the original height of the pole. Okay, so make sure you answer the question that's being asked. Go ahead, just try number 4. I want to find the original height of the pole. So go ahead and do that real quick.
You can do the nearest tenth of a meter, but I guess okay. So yeah. Careful. Not that. Just that. Sorry, I know you just been struggling ever since you did that quadratic equation. good. Yeah, very good. You got it. Make sure you're answering the question that's being asked. Okay? Make sure you're answering the question that's being asked. Good. Good, yep. Yes, good, good. Yes, good. Good, good, good. Yes, good. Make sure you're answering the questions being asked there. So, yeah, that works. Or you can't, yeah, that's that. And you can, so you can actually find that, right, because you can, to the nearest tenth of a meter. So you can actually, like, do that, get a decimal round to the nearest tenth, and then go that way. Okay. That looks better. You know how to do square roots with this? It should show up when you turn it sideways. You unlock it. It should show up. Alright, very good. You got it. Cool. Alright, so yes, right? So we've got
All right, so Elizabeth, did you come up with an answer yet?
No.
Not yet. All right, we'll call someone else then, because it did have your number come up there. Adam, what'd you get here?
I got 16.7 meters.
16.7 meters. How'd you set this up?
I set it up as 7 squared plus x squared equals whole squared.
Ah, okay.
Set it up wrong.
Right, so that's how we should set it up, right? 7 squared plus 12 squared equals x squared. Okay. So there you go. So we square both of those. We get 49 plus 144 equals x squared. Add them together. 193 equals x squared. Square root both sides. You get x equals 13.9 meters. All right. So are we done, though, Adam? Once we find this length x, it's 13.9 meters. Have we answered the question? The question says, what was the original height of the pole?
You have to add that to 7.
There you go. 20.9 meters is the final answer there. Okay. So yeah. So be on your toes, right? Some of these are pretty, straightforward, and it's just like, but we can get into, habits of just being like, all right, square plus square equals square, and then just solving. But we got to make sure we're answering the question that's being asked. So just be on your toes a little bit there. All right. So that's all we'll worry about with those ones. And then let's go on to some of these ones that have no pictures. So sad. So sad. Okay. All right. Man, I'm trying to see. These are all pretty straightforward, I think. But we'll give this a shot here. We'll say I don't know. Let's do number 3, Scuba Diver. That sounds like fun. All right, Scuba Diver has a rope connecting the dive boat to an anchor on the ocean floor. The rope is 90 feet long. The water is 40 feet deep. To the nearest tenth of a foot, how far is the anchor from a point directly below the boat? So it looks like the anchor is not below the boat. Okay, false alarm. False alarm. That was weird. So anyway, all right, we got some water here. We got a little boat. Okay. Nice sail. This is the dive boat. Okay. And then we got the ocean floor. All right. And there's the anchor, not really below the boat, so I'm going to put the anchor like somewhere, I don't know, like right there. There's our anchor. Okay. And so the scuba diver has a rope connecting the dive boat to an anchor on the ocean floor. So there's our rope. It's probably not like super tight, but we'll assume it's like roughly straight. All right, so there's the rope. And that rope is 90 feet long, so obviously then we've got the 90 feet right there, yeah? And the water is 40 feet deep. So I say, okay, that's like basically 40 feet deep, right? And then there's tenths of a foot. How far is the anchor from a point directly below the boat? So from directly below the boat, we would know this distance. What is that? So we'll call that x right there. And you can see that basically we have a right triangle here, right? Basically it's a right triangle. Basically we have a right triangle. Okay? So Drew, what would our setup be here?
40 squared
Uh-huh.
plus x squared equals 90 squared.
Yep, exactly right. That rope is the hypotenuse, and so then we'll just square, so it's like, what, 1,600 plus x squared equals 8,100. And so let's see, we get 6,500?
Yeah.
Is that right? And square root both sides. And again, a decimal is fine here. I'm going to put a little squiggly equal sign, though, because we are estimating. And we estimate to be about 80.6. And that's, again, in feet. Okay. I don't know. Would anyone like to see another one of these? You want to see another one? Oh, your question.
Why are we not finding the exact, like, simplifying?
Oh, like why don't we just say the answer is square root of 6,500 or something?
Before we were doing, we like simplified to 6,000.
Oh, like simplest radical form, you mean? We could, but generally when it comes to, well, first of all, because of what we're told in the directions here. The key is what the directions say. So if the directions say, write your answer in simplest radical form, that's when you do the simplification with your roots and stuff like that, like the tree, okay? Here, the directions say, to the nearest tenth of a foot. That means round it. So you actually just calculate it, use your calculator, and just round the answer. That's it. So that's the difference, okay? The directions will guide you as far as just what you're supposed to do, all right? Okay, so I know I printed out all this stuff, and I know you guys really probably don't want to do all these, and I feel like we don't need to. I feel like you guys got this. So we'll just stop right there, and I'll give you guys your assignment. How about that? Okay? That sounds like a better deal to me, I think. Better use of your time. That way you can get started on your homework. So I really feel like you guys have this. So I don't know if we really need that extra practice. All right.